Welcome back, Math lovers. Today I brought some interesting problems to discuss with you. Question 1, we are saying in a library there are n different books on mathematics. One can draw any number of books if the number of ways of drawing books is 4095. Then what is n is the question. So here you have to understand there are n books, and we're asking the number of ways of drawing books from this is 4095. It's meaning you should draw minimum of one book. So that means from n books, if you draw one book, it's like NC1. That will be the number of different ways you can do that. Or you can take two books out, or you can take three books out. So all these are success cases according to a question. So on till taking all the n books out. So this is given to be 4095. You can understand this. These seem to be the sum of binomial coefficient along any particular nth row of a Pascal triangle. So this is just excluding our NC0 term. So we can insert our NC0. So we know NC0's value is actually 1. So I wish to insert like 1 on both the side of this equation. So 1 is NC0. So NC0, NC1, NC2, NC3, so on till NCN. This is like adding up all the binomial coefficient along nth row, for which we know this addition will become equal to 2 power n, which is 4096. We know 2 power 10 is 1024, 2 power 11 is 2048, 2 power 12 is 4096, from which we get value of n to be equal to 12. So the question was just to find the value of n. We have found the value of n. Hope you enjoyed that problem. So we'll move on to question number 2. Question number 2, the question is the number of times the digit 3 will be written when listing integers from 1 to 1000. So here we can understand the digit 3. How many times will it be written when you list integers from 1 to 1000? So 1000 is the only 4-digit number that they're talking about. So leave that. So it does not have any 3 in it. So we can divide this problem into digit 3 being in units place, digit 3 in units place, tens place, hundreds place. So when we talk about hundreds place, so the numbers from 300 to 399 will have surely the digit 3 in hundreds place, and there are 100 numbers in this list. I mean, that means 100 times digit 3 was used in hundreds place. So how did I calculate 100? I have told you, when you count consecutive numbers, we have to do high minus low plus 1. High is 399, low is 300. So 399 minus 300 plus 1. So 99 plus 1, that only gives us 100. Now let's talk about tens place. So talking about tens place, so you have from 30 to 39. So digit 3 being in tens place, and this will come in all the series from 30 to 39, 130 to 139, 230 to 239, so on till 930 to 939. Okay, so we understand there are 10 sequences in this, and each of the 10 sequences there are 10 numbers, 10 times 3 has been used in the tens place. Again here it is 10 into 10, which is 100 times digit 3 is used in tens place. Finally, digit 3 being used in ones place. So we can talk about 3, 13, 23, so on till 93. So this will be again coming up in all the sequences of, so like there are 10 times things are being used here. It will be coming up in all the sequences of 103, 113, 123, so on till 193. So like that, they'll all be sequences till 903, 913, 923, so on till 993. So again here also it's 10 times, 10 sequences, so 100 times. Digit 3 was used in ones place or units place. So totally 100 plus 100 plus 100 makes it 300 times. Is that clear, students? Hope you enjoyed this. This is a very basic counting principle question. So you can actually remember this. So it's not just for digit 3. So digit 1, digit 2, digit 3, digit 4, digit 5, digit 6, digit 7, digit 8, digit 9. All of this will have the same count. So digit 1 and alone will be affected because of this 1000 being involved in this question. So all of the digits will have the same number of times of usage of, which will be 300 times. So let's move on to question number 3. Next interesting one. How many 6-digit numbers can be formed in decimal system in which every succeeding digit is greater than its previous digit. It's greater than its previous digit. So talking about digits 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9, there are 10 digits. We are talking about 6-digit number where every succeeding digit is greater than the previous digit. So we can clearly understand 0 cannot be used here, because if 0 is used, there is no digit which is less than 0. So if 0 is used, it has to be used only in the first place. If 0 is used in the first place, then it will not become a 6-digit number. It will be just a 5-digit number. So 0 has to be ruled out of this. So meaning what we are going to do, from the remaining 9 digits, you are going to pick 6 digits. Since every succeeding digit is greater than the previous digit, you cannot repeat any digit here. So from this 9 digits, you have to pick just 6 digits. And once we pick the 6 digits, which are all unique, you can arrange them according to the given rule in only one way. So there is no permutation required here. So the answer for this question will be a very direct question. The answer will be 9C6. So just 9 factorial by 6 factorial into 9 minus 6, 3 factorial. If I expand this, I get 9 into 8 into 7 into 6 factorial. So 3 factorial, which is 3 into 2 into 1. So 3 3s are and 2 4s are. So final answer that we'll be getting is 84 numbers. Hope you enjoyed this collection of problems, people. Let's meet up in another video.